So let's talk about complex piping. As I told you before, for example, branch flow, it's a very common concept on complex piping. Even many piping is also called complex piping because you cannot do this in an Excel menu. Maybe you have many information that your computer will blow up because you're using Excel. So you need a specific software, or maybe you are using parallel flow with a lot of flows right here. So whatever case you're using, eventually you're going to find out that complex piping is very common in engineering. So they are too complex to do, or not complex, very not worth your time to solve them because we have softwares. So let's say the problem many times is to know where the flow is going, as I told you before in the branch flow. If I were to show you a pipe diagram instrumentation of a plant, many times you don't know where the flow is going. Sometimes you do know, but you need many times to ask and be sure, because one thing is what's wrong and another thing is operation. You have a drop on pressure, is it still going to flow that way? If the velocity drops or the velocity increases, what's going to happen? If the size of diameters, maybe you don't know, and real life diameters are different than the one in the drawings, height, and also other stuff. They might seem like common sense, but actually for the software, the good thing is that this is not common sense. There are now variables, so that's a good thing. Of course, basic principles on Bernoulli equation and material balances, pressure drops, and so on still apply, but a little bit more complex. Actually, not a little bit, very more complex. And many times, the good thing on software is that they do iterations way faster than humans. So when you click run, it doesn't mean that they do it in one calculation. It means run and do a lot of processes until the answers make sense, until the solutions, all the variables make sense. So that's the good on software. Uh, Spreadsheets, actually try to avoid them. You're going to probably use dedicated piping software. For example, this one is branch flow. You got the sizes and stations, valves, and so on. And well, that will be a normal problem. This will be a model on space. You got all the piping. As you can see, this will be not nice to model. Probably you will model this little guy right here, goes to this guy right here, and it's easy to model. But imagine doing this and then taking into consideration this one guy here, the drop on pressure, and so on. So probably you are not going to do it. You're just going to plug it into a software, and I'm going to show you the typical ones, or at least the ones I use or heard about, or the typical ones in the industry, which is ROR. This is actually pipe in German, typical German engineering, of course. This one right here, I don't remember the names. I'm going to show you in this section below, but you can model these, and this is pretty awesome. Actually, this one right here is selected. You can even choose the type of welding and so on. And they are also very dedicated for pipe. You can use Aspen software, but that's not that complete. In piping, actually, there are not that many pressure drops. I will recommend RAW, it's okay. I'm going to show you a list of software that you can use in order to model pipes, but I'm pretty sure you're not going to use it. And if you use it, I'm pretty sure that the industry that's going to ask you for, or model for, or analysis for, they're going to give you the software and they are going to show you how to use it. And actually, the scope of this course is not to show you how to use those software. I just wanted to show you that there are plenty of software out there that you might use. And this is everything on piping software. I wanted to show you Recall that complex piping is not worth doing by hand. Even though mathematics are very nice, you will not probably like to do it. This was a free preview. You want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, you were analyzing or studying pumps, you have it here, the pump block, then you have the sections. If you were, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. You were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.